it seems to be we have some problems at Kherson State University. But just in time, we need to. Oh, yes, Andrei Mykolaievich, right? Yes, we need to start just in time our session. So I would like to introduce the talk of Dmitro Sergeyevich Antoniuk, Tatiana Anatolyevna Vakaluk et al. Using a business simulator with element of machine learning to develop personal finance management skills. Dear Dmitry, are you ready?
Yes, I'm ready. Thank you.
Yes, let's start.
Hello, dear visitors. Today I want to present you our study using a business simulator with elements of machine learning to develop personal finance management skills. We developed this topic together with co-authors who are Tatiana Vakaluk, Vladislav Titkivsky, Alexander Vizgalov, Oksana Alinik, and Valentin Yanchuk. So personal finance management is a really crucial skill for everybody in our country and all over the world. We see that the world is developing. Usually, mostly, it's developing to the direction of free will of the person. But together with free will, we also have some liability added to what everybody need to do within their life and decisions that they need to make. So this is why we are studying possibility to really improve personal finance management skills of people. And we are researching the area of using business simulators to improve this knowledge and this competency of the people. In our survey conducted already for 2 years, you see the results of for 3 years, you see the results of 2 years. I will add something shortly what we see this year, the difference. So in the survey conducted about personal finance knowledge, skills, and sources of the skills, we found that in 2019, 70% of people consider themselves as personal finance literate people. And in 2020, this percentage increased. It's not here because it's quite new findings. So raw results also shows that this year, even 78% of people consider themselves as financial literate. On the other side, what we see interesting, you can see it on the second chart, that in 2019, 45% of people had any kind of trainings in personal finance and in economic in general, within special course or within other courses, but having just part about personal finance. And what we see is this percentage significantly dropped in 2020. Only 19% of people really had any formal training or provision of the knowledge in the area of personal finance. What we also see this year, in 2021, only 16% of people surveyed. Mostly the survey was conducted with the first-year students of Zhytomyr Polytechnic University, people who attended IT specialties. So only 16% of people had any formal training in personal finance within their life until the first year of the university. What's interesting, in the same time, we can. This is a question about either people consider themselves ready to manage personal finance of themselves and their family. And as you can see, like 14% think that they have excellent readiness. It's a bit less in 2020. Also, like 38 and 46% of people respectively think that they have quite a good knowledge and skills and competence to manage their personal finance. So we see the difference in what people think they are able to do and what potentially they might able to do, because we didn't see any formal trainings. And just to check this in a more interesting way, so here you can see the results. These are questions. It's really raw material. This is why it's in Ukrainian. I added this just today because we got this result just recently. So we see that when we ask people how much yourself or your family spent, your family or Ukraine as a country spent for your education, you see that all the answers are around either zero. So people think that they are studying absolutely for free for themselves, for their family, and for the country. Or you see the results, it's 25 or 28,000. So actually, it's a cost of study. Who are not a budget paid students. So really people don't see about any other cost of their study, nor additional cost of, you may find that some in more detailed questions, somebody think about additional cost of living and so on, but nobody really think about lost opportunities while they are studying. So we see a really huge gap, which we need to fulfill. Our hypothesis is that using business simulators may really help to develop skills and competence of people, because we see the development of online gaming and other gaming in a broad sense. And business simulator helps us at first to make this process a bit more interactive. And secondly, we may develop also more skills and personal approach to the personal finance, and develop some feelings, because as I also saw my colleagues later will talk about, there are quite some difference between what is rational and how people will really behave in a particular situations. So we developed a business simulator which incorporates main functionality which private person a bit more in Ukraine, but also it's more or less similar for the other country, might encounter in their life. So they may work with different currencies. Person may work with different financial instruments like deposits or deposit certificates in some country, with credits and other financial instruments. Also, people may save some money and invest some money. So we differentiate just emergency saving, short-term emergency savings, and long-term investments. Main financial blocks you can also see here. It's different type of accounts, like current account. You may open a current account in other currencies. You may exchange your money to other currency if you consider this reasonable. You can also manage all that accounts in the future. So we have basic functionality of the simulator, and we have more analytical analytical research and some conclusion part. So first of all, person himself and administrator may see what happens within the week. So what for every week. So how much person has on their current account. So it means just money, regular money, which do not bring any interest, but also are quickly available for any kind of spendings. Also, we can see savings and we can see investments within a period of time on a personal accounts of the person. Within this simulator, also we took an approach we use in our surveys. So we have some formal assessment. For example, here you can see an example on a particular week of the simulator. Person gets formal assessment of their knowledge in savings, what's reasonable to save, and how much. So in the same time, we also conduct assessment of what a person is doing automatically. So it's included in the simulation. To make simulation more similar to real life happenings, so we added some unpredictable events. So it's not only actions people can really calculate upfront or make rational decision. So people can find themselves in a situation when they need to manage unexpected decisions. Like in this case, you see that person got influenza, and person will need to spend some money to work with that within the period. So also on the right side, you can see a report. What we wanted to do, it's a bit plans for the future. We want to compare behavior of people with per country. So we want to compare. We did some training. Still, we don't have enough data on the people of other country. We want to study the difference in approaches of people in a different country managing their personal finance. So in general, about using business simulator in general, what we can do within our present simulation, it's using the diversified list of currencies. We can form a widely acknowledged standard of emerging savings and readiness to investment. We can train and assess basic knowledge in a basic and widely shared financial instrument, and also work with a debt management and forming some personal behavior attitude towards personal finance. And the second big part of our simulator and our approach is to use reinforcement learning, and as one of the part of machine learning approach to try to find what's optimal or not optimal, this what is how we can optimize managing our personal finance and compare that to what real people are doing. So we are using a reinforcement learning approach. It's pure learning algorithm. It's value-based algorithm. So we don't try to create some real policy upfront. We let our model to try work in our environment, in rules and instruments we have, and try to find the best way to manage finance within period of time. So after we create a model, we used ML Microsoft library for reinforcement learning algorithm. So MLRT. So we used standardized solution for that. We train the model and compare it to the behavior of real people. So first of all, about training the model. So what we see, we studied different approaches to model trainings. Unfortunately, for now, and this is also plans for the future, so we found that this model can reasonably work within the scale of within the time horizon of 24 to 25 weeks. After that, we need much more time to train this model. So we use this time period. Also, we found that we need 1,000 training attempts to have model trained good enough, because after 1,000, final results and final efficiency of the training really doesn't grow that much. So 1,000 attempts to train the model. And we use that model to assess our future results with the students. So what are findings? On the right side, you can see the difference. Typical difference we found in effectiveness of managing personal finance, but by our trained machine learning model and real people. Also, you may question why our chart has such a form. Using personal finance investment instruments like deposits or deposit certificates, you usually have payments once a 3 months or once a 6 months. So this is why once you get your interest and your money back from deposit or something, so you can see significant increase in your account. Also, when you invest money or you put money on deposits, you can see amount of money going down. So this is why our charts are not really smooth, but you see the significant changes within the time. So you can see that our RL model shows significantly higher effectiveness in managing money. And also what's possible to see in our next our next slide, that efficiency of the model really grew if we changed parameters of available money to manage. So if we increase total income of the person and make the difference between total income and total expenses bigger, so person has more money to invest, we see that with more money available, our model became even more efficient, and the difference in efficiency of the model and real person really grow a lot. So these are findings for now. What our future plans around this simulator and this approach are? We want to really try to share effectiveness of the machine learning models in managing finance with people. So doing that, we acknowledge that we cannot really improve outcome significantly with people just teaching them with a usual or standard methods. We need to, in the future, we need to find possibility to match personal characteristics of each person with approaches, with investment instruments and investment schedule, investment approaches and saving approaches with the person. So we need to build model of the person, more or less. We need to find appropriate instrument to improve readiness of the person and to invest more effectively, so to get more personal financial benefits and be more ready for the life. So this was we consider this study successful. We have a lot of initial data to continue a study, and we will be really happy to answer your question if you have them. Thank you.
Thank you very much. Question for presenter the activities.
I will start. Dmitry Sergeyevich, first of all, you use, it seems, Q learning and build a Q table. It's a discrete method. What's your time unit? Is it 1 week or 1 day or some else?
Do you mean time unit to train the model, or what?
Yeah. Yes.
So to be able, like we all know that we have some limitations within which we conduct our experiments. So we found, and this is why we used only one moment. We were using 24 weeks as a training period because for this period our training time was around like 15 minutes. So we could continue our experiments a lot. And after that, time for trainings grew significantly. So like we tried with our resources available for time around 24 weeks for trainings. It took around 10 hours to be trained. So what really influenced our ability to experiment more. So this is why our normal training attempts took around 10 to 15 minutes, because after that time to training grew significantly and negatively influenced our possibility to experiment and try other approaches to improve our model and our system overall.
Also, I want to add, in addition to answer, that the time unit for Qtable was 1 week, and we had specific action spaces for that 1 week. So these action spaces included the possible actions for the user to choose for that period of time. So, the answering the question, the time unit was the 1 week for Qtable.
Yes, so also here are my co-authors who were responsible for different parts of this work. So also Alexander answered more technical question.
Thank you, Alexander. Next question to Dmitro Sergeyevich. While you plan a personal finances, we need to involve and ordinary decisions during illness, during pandemic, death, or else. Which data you use to train your model? What types of family on the age or illness or other parameters you use? Or you use some young family of middle age or old family to train?
Yes, thank you for your question. Also, this why we chose reinforcement learning as an approach for us to study, because it's especially in Ukraine, it's very difficult to find reasonable data sets. And as you really correctly answered about the period, so we like big part of this work were conducted in time of pandemic, where all the previous patterns were really damaged. So what we've done in our work, we've introduced a set of standard savings and investment instruments, or vehicles, how it's called in a professional area. So we introduced instruments, and we trained our model to use available instruments and rules we introduced more efficiently. So as we found during our work, model really studied quite effective, studied to be quite effective within our set of rules. Also, in the same time, we were experimenting with real people, working within the rules of our system. Because we situation is when we collect data is from the past, and past doesn't have all the possibilities, all the instruments, and the past doesn't have the reality we have right now. So we work with artificial model created by us in the simulator. We used real instruments, so we really used present parameters of instruments available, but we didn't use any real data from the past. So we created model, trained our reinforcement learning model with the financial model we have, and we experiment with real people.
Thank you. And a last question, if it's possible. The main idea of your long-year work is to develop a personal, or not only personal, financial skill using business simulator, or else. Do you compare this current approach presented in your talk with your previous try to solve this problem?
Could you please specify the question a bit?
First of all, the main indicator, the level of financial competence. It will be really increased using this approach or no?
So it's in general, it's very big question. Personal finance management competency, it's much bigger question, which consists, as you mentioned, skills. Usually we need knowledge, skills, and the main and most difficult part, especially in developing society, it's personal approach, because we are living in society which was absolutely different 30 years ago and quite different 10 years ago. And if we have developed countries, they have more stable timeline and approaches. So we, like with this simulator, we want to work more with a personal approach, personal understanding, personal feeling, and personal readiness. So we want to show like what we are working just with a part of competence building. We want to let person experience savings and investment possibility within longer period of time. To experience is firsthand, because and we work just with this limited part of competency building, because usually it's very difficult in real life, and this is why simulators comes in handy when we cannot do it in real life with this time span in our case, and with this wide range of instruments. Usually they are less available for normal people. So this is why we work with this part.
Many thanks for your answer and for your kind support to build our personal competencies in this question. Any other questions? I think it will be.
Thank you very much. No question.
Thank you. Shall I?
Well, we invite to the presentation Svetlana Vasilenko. Svetlana.
Okay, good day, dear colleagues. Okay, we want to present a research which was carried out for several years to model the internal certification system of educational resources for blended and e-learning in higher education. We describe the precondition for the internal certification system modeling and features to recent changes in the process of it, approved by the university regulation, which is related to the requirements of the situation of COVID-19. According to the aim of our research, we have achieved very important results and have the following advantages: quality educational resources, expanding access to educational content, the individualization, improving the quality of efficiency and improving the quality and efficiency of the education through the use of digital and innovative educational resources, monitoring of the quality of education. Our research took place in 3 stages. At first, in 2012, we created a pilot model. Next, in 2012, from 2012 to 2019, we had approbation of this pilot model, and after that, for the last 2 years, we developed the internal certification system. Resources for the teaching and learning are created in the e-learning system and are systematized according to the academic or educational professional programs in the e-learning course, ELC. Each discipline is provided with an e-course which can be fully developed or completed in the process of deploying the educational program. Personal digital office or personal digital cabinets for users were created in the e-learning system for effective work of teachers, students, and administrators. It provides quick access to useful digital resources. As class schedule means to communicate and cooperate, libraries, e-portfolio, etc. The developed ELC is the intellectual property of the university and must have a unified structure and meet the general characteristics and requirements. Structured teaching and methodical materials, logical configuration of the discipline studies, clear schedule for our students, the system of interaction, and so on. The first section of each ELC is its describing, which indicated the academic and educational professional program, name, level of education. Also contains the reference to the actual discipline syllabus in the institutional repository, general information. You can see all components on the slide. Each content module consists from theoretical materials, practical laboratory works and seminar, task for individual work, and modular assessment. ELC have a formative assessment as a modular control and a summative assessment as a final control in the form of an exam. ELC also contain different additional materials as video, ebooks, some recommendations, examples of student work. On this slide, we present the model of the ELC internal certification system. The main process in this system are ELC design, ELC design, recommendation for ELC creation, I've mentioned earlier, organization and conduct the expertise, analysis of expertise results, and certification decision making. The ELC certification decision is made by the Methodical Commission collectively based on general conclusion of the director or dean of the structural unit based on expert opinion. Therefore, both teacher and students get the benefits. Authors should initiate ELC certification and take the following steps. First, they should send a request to ICT assistants and director or dean of structural unit. Then they should enroll experts in your ELC, and at last they should monitor and respond to the results of expertise through the viewing special table online. The results of each stages of certification are reflected in a free-to-view document, which allows also to make adjustments to the submitted ELC in accordance with the recommendation. Viewing the results of professional expertise, one of three, is open and available on the corporate account. During the professional expertise, scientists assess and determine in online form the scientific level of the course material, the correspondence of all created resources to the syllabus, the relevance of the content, novelty of submitted materials, its completeness and logical consistency, content and methodological expediency of the created resources, methodological aspects of the course organization, pedagogical and psychological basis of organization of students and pedagogical staff's education activity. In a pandemic, the university's educational process was organized using e-learning system. The number of ELCs created in 2020 has almost doubled compared to 2019, which made it possible to provide ELC to almost 19% of disciplines. 60% of which are fully developed and fully used in the study of disciplines. Others are gradually filled with educational content and used for keeping a log of assessments. Students rate the ELC according to the proposal's criteria: clarity, accessibility, topicality, creativity, and expediency. The decrease in the student's assessment is caused by the creation and simultaneous use of ELC during the pandemic in the mode of full distance learning. Among the reasons are the teachers and students met technical difficulties. In 2020, teachers began to use the e-learning system in extreme conditions. Not all were fully created ELC. Some ELC contained only the checkpoints for scoring to form a journal of grades. So students objectively more rigorously accessed ELC in the e-learning system, already having a large number of ELC for comparison. The analysis of evaluated ELC confirms the use of ELC that were filled with content at the same time as the classes, as only 22% of the evaluated ELC were certified, and accordingly, the level of evaluation of such ELC average from 4.6 out of 5.0, which remains at level of 2019. According to the results of student assessment, certified ELC are qualitatively developed. The resources presented to them are clear, accessibility, relevant, creativity, expediency, and they are sufficient to master the discipline. The positive trend of increasing the number of certified ELC confirms the need of them by students and teachers. That is why the introduction of the internal certification system justified an important role in the preparation of quality educational resources and, in general, in the modernization of the e-learning system of the university, now and in the future. In conclusion, I must say that the system of internal certification of educational resources for blended and e-learning has been developed in Grinchenko University. We can recommend it for implementation in higher education institutions. The three independent and diverse expertise and evaluation of ELC by student ensure high quality educational resource, and as a result, the quality of educational services. The system of internal certification encourages teachers to increase the level of technical and professional competence. That's all. Dear colleagues, I thank you for your attention. On this slide, you can see our information about our contact. Thank you very much. Do you have any questions?
Thank you. We have a question in the chat.
Okay. Just a moment. I open the chat.
I don't see.
Thank you very much. We work together with Natalia Morze from 2012. Yes, okay. All students should be evaluated both their protocol and courses. Thank you for your qualifications. Thank you very much. I have the capabilities of the model to conduct video session in learning. Use Yes, we use all capabilities by Moodle, our e-learning system, construct on this platform. We used a different type of resources, video too. We made it in our studio. I'm now in studio of distance learning, and we save our video in a corporate Google account on YouTube or in eDisk, Google Drive, sorry, and switch on this video in our course as a link. Include a link for our video in our e-course on Moodle. And so we have different ebooks, we have presentation and so on for visualization, our information, for lectures, instruction to do some practical or laboratories works and so on.
Thank you. Can I ask a question? The learning courses and learning program can be changed time after time. Do it needs to recertification?
Yes. Thank you very much for your question. We have
And
the main question: which percent of course should be changed to need to be recertificate?
yeah.
every year we have a prolongation of our syllabus, and our e-course must be must answer all criteria for the syllabus. That's why the status of certificated ELC, all e-courses have only to 1 year. Only to 1 year. And in August, we have a big roster for e-courses to continue the status of certificated. We said this procedure as prolongation.
Well, have you another question, please? We have a question. More question. Thank you very much.
Thank you.
Welcome to presentation. OC Ignatenko.
Good day. Yes. Yeah. Can I present only my file? I can only present my screen.
Okay.
Yeah. Is it fine?
Yes.
Yes.
Okay. Sorry, I had some allergies, so my voice may be a little strange. My presentation and my paper is entitled "Guests in Games Experiments in School Education: Learning Towards Equilibrium." Sorry, it's So plan of this paper is tell you a little bit about game theory and then about the experiment I've made in different occasions and present the results and analysis, and also present agent-based model to explain some interesting occurrence and tell you about key findings and the future direction. So first of all, for one who do not familiar with game theory, right now modern game theory taxonomy is about theory. It's a complete information games, incomplete information games, and how to calculate equilibrium. It's algorithmic game theory, and also behavioral or experimental game theory. And this is about how people behave in different setup, and sometimes they behave differently from theory, because theory actually built for rational players, but people usually not rational. So when we talk about game as a mathematical object, we need to define set of players, set of strategies, and payoffs. And with assumptions that players are rational, it gives a tool how to understand and analyze an equilibrium. So we can imagine equilibrium as a result of playing of ideal players, players who are totally rational, knows what they will do in any situation and how others will react. And this coordination and interaction, they produce ideal possible result, best in some sense for every player. But in reality, people, of course, do not do that like this. So this paper is about how people behave in different guessing games. Guessing games is a broad name for area where you have very simple rules. Usually you need to choose some number, and there are rules how to define a victor, how to name a victor, to who will win if some players choose some numbers. And one of the first experimentator or researcher who investigates this games was Rachel Nigel, and in her dissertation she present a beauty contest game, and later many other like Kammerer and other researchers, they also investigate this game in laboratory conditions. And the recent trend is to find the theoretic model of mind to explain how people behave in this game, because usually games that played in this area, they usually played with adults in laboratory conditions where they are like very serious about the result, or during courses on game theory where students also quite serious about the result. So almost no experiments are with school children or kids due to complexity of such setup and permissions and so on. And we can note also that experiments in this setup are generally reproducible. So very different groups behave in quite similar way. And also I should note that data usually not available. Very few researchers, they actually put their original data set in some resource to investigate. So we try to produce a good decision, and we provide. I provide this data set to the public, and everyone can use it. So in this experiment, usually these games were played during the lectures about the game theory. So I gave lectures in schools and different group for different groups, and participants were not rewarded for win. They just, there was an announcement that this player is winner, but no more. And we use possibilities that were provided with mobile phones, so it's very simple to put decisions in a Google spreadsheet using some stuff. So you need, but you need to control this. So there's a problem with the number of submissions. So strong sides of this setup is that it allows to measure how people make decisions in almost real circumstances. So no gravity of serious situation. It's fun, and it's very usual how people behave in real life. And these games were part, you can say, an integrated approach to active learning, because here, in contrast with laboratory condition, I explained the idea of equilibrium between first and second round. So they actually, school children or adults, they have knowledge how it is theoretically better to behave. And third is freedom and responsibility, because rules actually doesn't regulate manipulations. And sometimes we found that maybe one player produce a few answers, and it's difficult to so they players could cheat, but very few players actually cheated. So weak sides, that some percentage of players, they like in real life, they make garbage decisions. They just do something without thinking, and they have possibility to talk decision with about the decision with other neighbors, and sometimes they lose concentrations. So if you have a long lecture, at the end they do not play well, and sometimes they fail to understand the rules, and it was like obvious from the results that they just put some random numbers. So game one, rules are very simple. Choose an integer number from 1 to 100, then everyone choose this number, put on the paper or in Google spreadsheet somewhere. Then we calculate average. So players do not know choose strategy or choosing a number of other players, and the winner is the player whose number is closest to 2/3 of average. And this is a classical setup. And if you consider yourself, try to think what number you can choose. Well, as you see, this is a result of round 1 red and round 2 blue, and you see that the difference between rounds, and round 1 is like distributed and round 2 is closer to smaller numbers, and this is the case. So if you consider the situation between first and second round, this is for different types of players, because every game was played many times. So as you see, sometimes the difference between first and second round is quite big. You have a dramatic decrease of average in second round. Sometimes it's not too big, because for example, number in first round was already too low. So if you have rational players, then people make decisions based on maximizing utility, and here utility is the desire to win. So if you have, for example, any, you can name any number, but if everyone choose 100, then you can understand that the winning number is 66, and situation when everyone choose 100 is so rare and so unlikable. So naming the strategies, naming the numbers more than 66 is like dominated strategy. It's a one of the baseline of game theory. Rational player do not play dominated strategy because it's worse than other strategies. So rational player should remove dominated strategy, and if rational player will remove it and everyone do this, then next dominated strategy is do not name numbers more than 44, and so on. And you had idea that everyone choose win and everyone wins, but never people choose one on the first or second round. It's just impossible. So because of learning delay, and you can measure this learning delay, actually this is this is what in game theory is called common knowledge. It's common knowledge. If I know that everyone will name one, then I will name one, but I don't know that, and others also don't know. So people do not have common knowledge. They learn in the process of this game, and there are few models how to model this process of learning in very simple model, but it's like rich for investigation. So there's an idea of an angel about K-levels. K-levels means that every player has like own level of thinking, and 0 level means that people name numbers randomly, and first level means that they try to understand that other name numbers randomly, so I will name so average will be 50, so 2/3 will be 33. So first level is to name 33, and second level is to understand that many will have first level, so I will name 22, and this is the best response for everyone else naming 33. So it's like reacting for reactive beliefs. Also, there is a reinforcement learning idea about that people try to reinforce their beliefs about what other player will name, and weighted reasoning and other. And the main problem, as I can judge about all these models, is that they do not include irrational behavior. Because if we return a little bit, for you can see this in the paper in more general. If you see that sometimes the number of big numbers on second round is bigger than number of big rounds on first round. Big numbers like 100. So it's very strange, because it seems that children, they try to spoil the game. They name big numbers just for fun, and this is the element that is not included in any model right now. So we in the paper we propose the idea of 4 types. It's like we have initial type, we have first level, second level, and infinite level. It's like those who names very small numbers, and this 4 types is actually quite sufficient to understand what is going on, and we can produce some general results. This is a if you put on the plot winning choice in first round and in second round, you can see that they are gather like tight cluster, and this is how almost every group like have similar behavior of understanding. And if you put on the table this difference in levels, you can see a few general things. For example, after first round and clinical concept explanation, there is decrease in B level and M level, and symmetrically increase in 2 other levels. And so another interesting situation is if you consider the size of the group and win independence. And if you see this is a number of participants here and winning choice here, and you can see that this slight decrease tendency, maybe not very explicit, but if you have a smaller group, it's distributed, and if you have big group, it's like less distributed. So this is about Nash equilibrium. If you have understanding of Nash equilibrium and belief about other players, this is how you can play this game. Understand that everyone should play this. And our point in this paper is that people actually have the understanding of Nash equilibrium without formalization. And if you formalize, it makes the, especially after the game, it makes them learn faster. So if you consider game number 2, it's about choose integer from 1 to 100, and we calculate average, and the winner is the players with the most distant number from S. And here players should understand that if you choosing 50 is no point, so they're dominated strategies. The two best strategy is to choose 1 and 100, and if we consider the result, we can see that actually it's the real choosing is very close to the ideal situation, because ideally half of them should choose 1 and half of them should choose 100, and this is the Nash equilibrium. And in reality, you see that average is almost very close to 50, so as expected. So third game is choice. You should choose number, and the number that is choice of maximum amount of player wins. So if two numbers has the same amount of choices, smaller wins. And this is a coordination game and quite interesting. So first, these rules have two interesting points. First, any number can be equilibrium. If everyone choose 100, then everyone wins. So it's fine. But if you have like 5 of them called 100 and 5 of them called 99, then 99 wins, and because they have like the same number. It's a almost impossible situation. Very small probability that two numbers get the equal number of choices. But this rule, which is have like 0 probability to occur, this rule actually launch the line of thinking that smaller number is better than bigger number. So it is quite rational to name the smallest possible number. So in this game, everyone choose actually 1. And this is famous because of Thomas Schelling investigation. This game is famous. And so in this case, the result explained in the paper. You can read it, and this part is quite good reproducible. And yeah. So there's also a fourth game, and fourth game is quite interesting because there are no right now, as far as I know, there are no theoretical solution to this game. It's like very simple rules, but without a theoretical solution. And almost any number can be a winner, and that's why it's interesting. So during the preparation of paper, I got like suggestions that it's good to not only observe experiments and try to build some model about how people behave, but it is good also to make something like active model, agent-based model I choose. So participants are agent to investigate, to have a tool for investigation this process. And I tried to include in this model the irrationality of players, when players getting angry. So participants are agents, and they make choice every round, and they know previous winning number and try to adjust to it. So they try to predict next winning number, and they have different levels of reasoning. So they have different levels of reasoning. What is the how they can adjust to the winning number. And some of them do irrational choice when lose too many times. So if agent try to lose hard, and after few rounds it gets angry and try to name like 100. And I built this model in NetLogo system. This is a specialized system for agent-based modeling. And as you see, there are some interface. This is an interface, and you can set parameters about levels of thinking, and you have histogram of choices produced and winning number, and also you have winning choice in time. And one of the interesting patterns that I observe, it's how to explain difference between laboratory condition and this real experiments I've got. And one of this was actually a spike on second round when the participants who didn't win previously, they get angry and they increase their numbers, and sometimes it's like a spike in so the average after the explanation, the average, the winning number is not increasing, decreasing, but increasing, and it was like strange because in laboratory condition and after all explanation, it should go to small numbers to 1 quite smoothly. So if you have rational player, it's indeed they just learn and they go to an equilibrium. And if you have a rational player enough big enough number, then you have this spike. So what we can summarize in this paper? Well, to learn the rules, you need to break them. It's I think it's like inevitable process of learning, and it is shown during this game that many participants, especially school children, they try to break the rules, they try to found the boundaries, and which is interesting. It's if you have 8th or 7th grade, they it's not that explicit as when you have like 10th grade. So it's like high school, they need to break the rules, so they try to found the boundaries of this game, how you can break it. If you consider the winning number as decision of the group, despite a few participants who tries to choose big numbers, group in a whole learn quite fast and steady. So if you have 2 more rounds, they are learning very fast to the equilibrium. So players unconsciously randomized in second game, as you see, it is mixed Nash equilibrium. So you need to randomize your strategy to get one, and players without understanding, without understanding that they play mixed Nash equilibrium and use randomized strategies, they do it anyway. So it's like hard printed in brain. And interesting also stuff about third game, coordination gates, that if you have choices from 1 to 100, always the 1 is always winning number, because it's like coordination. They very simple coordinate to 1. But if you have less choices, like from 1 to 10, sometimes other numbers also have chance to be coordinated around. So sometimes 3 can win, sometimes 5 can win. So it's like if you have a big amount of choices, you try to find slightest possible hint to get better one. But if you have less choices, it's not so obvious, because other consideration came into play. Thank you. So that's it. If you have any question, please.
Well, we have 2 questions in the chat.
Okay. Should I?
I can ask them by voice if it's okay for you.
Yeah, but it's better if you read them if possible. Thank you.
Okay, thank you for your presentation. Very interesting. So 2 questions from my side. One is technical. So what approaches did you use to simplify getting rid of garbage data of all types?
Well, I have when I use Google survey, this standard tool, we just remove all not integer data. So it doesn't allow to input non-integer data. And when we use a sheet of paper, we just remove if someone writes something like 99999 or infinity, we just remove this decision.
So it means that you work only with, so you remove only data which is really out of reasonable limits.
Yeah,
so
I had like rules that you need to name integer from 1 to 100. So this data is fine, consider it as fine. And actually we have funny accident where one person tried to put into our to results 10 different pieces of paper with decisions. one person, but we noted that and we stop it.
Interesting. And second question is more organizational, psychological. Do you have any recommendation how to better involve students of the secondary schools to play in these games? Because we understand that it probably will bring some value for them, but it will also bring value for researchers or like feedback for improving methodology. Any hints from your experience?
Well, usually school children are very interested in such kind of stuff, but they need explanation, because if you just play these games, they lose interest quite fast. Yeah, so you need to explain why it is important, why it is about decision making, why it is so interesting, how decisions are made by people, and how it's correlated with real life. So if you do this, I think they will participate in this game very gladly.
Okay, thank you.
And
well, and Sergei Alexeyevich is proposed the first game to
New
tournaments.
participants, new level, another data.
yeah, by no means. I actually I came unprepared. I don't have, but I don't have this link. But you can write your number in the chat, and if we all do this almost at the same time, then it will be fine. And I will write the result and say who is winner. So if it's okay, just write a number integer
Yes.
from 1 to 100.
The number from 1 to 100. Yes.
Yeah, integer number.
Mm-hmm.
Okay, so it seems we have a quite not rational decisions here, but let's wait a little bit. Oh, I see someone put 2 numbers. It's not. It's a rules violation. You need to choose what we will include, first one or second one. Okay, I will calculate.
Well,
Okay, let's
we must write on the paper our number, and
so right now 50 is the winner.
We simply choose an average only. But 2 participants try to choose a boundary. No.
Well, yes, it's actually a very rich game for investigation, and it's very simple, but it's a lot of stuff is going in when you try to predict the resulting number. Okay.
Thank you. Alexey Petrovich, one more, not question, proposition. As I know, you ready the next year a big conference, UKRPROG 2022. Could you announce this conference at this workshop?
Yes, of course. We indeed prepare UKRPROG conference. And this is a 2-year, once for 2 years. So next year it will be this conference, and yeah, I invite all you to participate. I think we will have a section about software and aspects in educational. So in education, and we are working on this preparation, and as soon as I will have this announced, I will send you. Thank you.
Many thanks.
Okay.
Thank you very much. And our next presenter, Zarima Saidalina. Please.
Can I have a link for sharing my presentation?
1 minute, I try to share your presentation.
It's a great honor to me to be here with you. It's a real nice conference and workshop. I knew Ilya Alexandrovich Teplitsky in person. He was a great person. He made a lot of things for Ukrainian educational system and for informatics, and that's why I am really honored to be here with you, and it was real nice session. Many thanks to all participants, all presenters, and especially for our two chairs. Thank you for having me with you, and I start my presentation. Because of our session is about computer modeling and simulation, I tried to, in my topic, to show what we need to do with students for make them more understand these concepts. This computer modeling, it's like became a widely tool for solving real-world problems. And it's like some abstract, simplified, accelerated model of some process or systems. And many concepts of computer science and software education are difficult for students to understand. Can we, next slide, please. And the course of algorithms and data structures is one of the most important subjects in computer science, and that's why we are looking some ways for effective teaching and for implementing some pedagogical tools and approaches for proper demonstrate of important topics of algorithms and data structures for students. And we try to find some effective approaches. For example, there are many approaches, and one of them, this flipped classrooms approach, is effective and widely used in subjects like engineering, educational technology, mathematics, statistics, and so on. And these flipped classrooms is also effective for for programming courses. And a lot of studies found that flipped classroom method facilitated learning, helped students to develop soft and hard skills, improved their innovative consciousness and attitude. And another tools is like that can be widely used for teaching is using visualization apps for teaching, especially programming and algorithms and data structures. Next slide, please. And that's why we try to find more, to know what is more effective using when we teach these algorithms and data structures. And the roadmap of teaching algorithms and data structures, it's like part one is algorithms and part two is data structures. And for teaching that, we use, of course, the classic book. One of the books is classic books of CLRS, Corman and other authors, and we use a lot of resources that of other universities and other researchers, and sometimes we try to make our own tools and our own video materials. Next slide, please. The first part is algorithms. It's like consists from 4 big topics, maybe. One of these we can teach students to analyze, how to analyze programming algorithms, and there are different types of algorithms, and that's why we try to know them, each approach, and then we try to make them know to like various types of algorithm problems. It's like comparison sorts, non-comparisons, or linear sorts, and some searches problem. You can see everything is on this scheme. Next slide, please. And the part two, it's data structures. Of course, it's like maybe simple structures, and they learn about this in previous courses, but it's really hard to make it more understandable for students. It's like non-linear data structures. It's like and hashing problems. It's really hard to them, and that's why we try to find maybe ways how to explain these things more simple for students. And next slide, please. We for traditional courses, we use lectures, homeworks, labs, and projects. And students all times they try to implement some algorithms, or maybe some create some structure, and etc. But it's, as I told before, it's really hard to students to understand which data structure is the best for some maybe in some points maybe, and in traditional when we teach in traditional way, it's like mostly teacher-centered and or student-centered, student-teacher such interaction. And of course, it's not enough, and we try to consider it in our during our courses. Try to maybe we choose 2 different approaches. It's like visualization and flipped classroom concepts. And during 3 years, we try to know what is better, or maybe we need to choose both approaches, or and etc. Next slide, please. For example, we choose for trees representation, it's like BST trees, balanced trees, it's like RBT, and ABL trees. And for visualization, we use I don't know, it should be animated slide, but and we need to.
One moment, I will try to animate a second or two.
Oh, I don't know. It's not. Maybe we use. This is not our app. We try to use the next tools that we find on this GitHub, and we try to use it. Of course, students and sometimes our students, they ask to implement their own applications for presenting this structures. For presenting these structures from GitHub, and I try to show you that how students, it's more understandable to them to know what is means this RBT trees and how to implement all operations, or maybe transversal or insertion, deletion, and so on. Next slide, please. And for this is another visualization of that is free for all, and we try to use it. And next slide. And this is and it's like hashing. I don't know why it's really hard to them understand such things like probing, perfect hashing, and double hashing, and so on. And that's why we use this visualization. And the next, our approach is flipped classrooms. Next slide, please. We wanted to know what is better maybe, or useful for using it in our work, and that's why we try to maybe design the experiment. And our experiment was we provide 2 experiments with 4 focus groups. And for the experiment, we choose 2 topics. It's like hashing and trees, because in our point, it's really hard topics for students. We choose 2 for 2 topics group for each experiment. First experiment with we try to know visualization. We choose 2 groups, A1 and AB. These study groups were prepared on the subject hashing and trees, and with visualization technique. We use this all visualizations of all concepts. And the difference between group A and B was that for groups A1 we applied visualization tools, and for group B1 we use traditional approach. And after that, we collected results using some 4 questions test, and each test was like half points, and we collected these results, and after that we try statistically to know which approach is better. For the second experiment, we choose 2 groups, A2 and AB. They also studied hashing and trees, but we use this flipped classroom concept for group A2 is a pedagogical approach, and for group B2 we prepare in standard traditional way without we use this whiteboard without and presentations, but not this flipped classroom approach. And in the next slide, please. In the first experiment, the number of students of group A1 was 28, and for group B it was 26, and for the second experiment it was for the group A2 31 students, and for group B2 25 groups. And we provide two tests, for one test for hashing and the second test on trees, on trees. And after that, we collected results, and the results of the test by groups are shown in this figure. It's for visualization approach, and we can see the results are better, of course, for this for group A1. Next slide, please. And these such results we have for groups that for this on topics trees. For we use this visualization approach, and maybe you can see as results for the trees topics is almost the same. It's like visually. Next slide, please. And the results for group for flipped classroom approach, it's like group A2. The results are much better than for groups B2. It's like three who has students that have had traditional approach, and this is for hashing, and for topics, trees topics. Please, next slide. It's like for groups A2, results are better. Next slide, please. And the results, you can see the results that we collected on this table, and on the left you can see results of their points of their students that they earned, and we can tell such maybe conclusions on this experiment, that the first experiments for groups A1, these groups used visualization, they achieved better results for trees topics than the groups who had traditional approach, but for these trees for BST, RBT, and AVL, results are almost the same. And for experiment 2, when we use flipped classroom, we see that for both hashing topics and trees topics, the results for flipped classroom is much better, much better. And of course, I think it's predictable. For this flipped classroom, we used all Moodle and Google tools and other tools that, because there are a lot of tools in the internet, in the world, we used all these tools, and of course we used this like videotaping. We used all our video presentation in Moodle. It's like BBB with BBB, and of course we used YouTube. And the next slide, please. It's like our conclusions. I told about these things, and you can see this on the slide. And of course, if you see the second experiment, maybe this flipped classroom approach is maybe most effective than visualization. But I think for maybe most effective pedagogical success, we need to use and visualization and flipped classroom and maybe other tools for students. And the last slide. The last slide, it's our students, they, during one of the session, they try to make their own problems. And maybe problems that I presented, it's not so global as than we than other presentations that we heard today before. But I think every educator knows that this is very important problems to improve the quality of education, the improve maybe to find new tools for more effective teaching and learning some real important topics. Thank you very much for having me.
Thank you. Thank you. And questions, please. Very interesting presentation. Really, it's important and interesting for this experience. Well, and we have not question.
We have a big impression, but really without questions. Thank you, Zarya Vasilevna.
Thank you very much. And last presentation today, it's presenter Olena Piatekop, using augmented reality in early literacy. Please.
Good afternoon. My name is Elena. I am an assistant professor at the Department of Computer Science, State Higher Educational Institution, Prezov State Technical University, Mariupol, Ukraine. I am very glad to take part in this conference. Together with my colleagues, we offer a report on the topic using augmented reality for early literacy. The technology that is currently being actively developed and implemented is augmented reality. Augmented reality technology allows you to combine the real and virtual worlds. You can supplement existing objects with virtual ones for a more visual perception. Augmented reality technologies are actively used in many areas: advertising, marketing, medicine, engineering, and much more, relevant to use in education. Literacy is a critical aspect to the healthy growth and development of young children. Since the problem of reading among elementary school children is especially occur today. To avoid problems in the process of school education, it is necessary to start learning literacy in the playful way at an early preschool age. Using augmented reality will make the learning process more fun and memorable. The use of augmented reality technology is a very promising direction for the educational system. This requires the portable software. Not every teacher can prepare a mobile program. Therefore, the development of a necessary mobile application is very important. Today, augmented reality potential for education is being actively explored. Each stage of education has its own key characteristics. We analyzed the application of various authors. Examples you see on the slides. The detailed description is given in the article. Through augmented reality is widely used at various levels of educational, such as higher educational, secondary educational, primary educational, and preschool educational. For young children, training is successfully carried out with a playful form. Motivation, fun, and pride are important ingredients in any educational game. Publication confirmed that this can be achieved using augmented reality technologies. The mobile application is seen as an additional element of interest and training and will not replace a fully fledged. The characteristic of competence of a personal achievement of a child is a result of educational activity of an adult with a child is considered by us as a sequence and emotional, while due to the formation of knowledge life skills. The listening activities of the child, the augmented reality technologies are states of work are possible of there are structural components of the learning model. We have different the construction of the teaching model as an emotional of the educational process of teaching literacy by creating a schematic order. The training model has evolved from figure 1. It reflects all the elements of signal system. A detailed description is given in the article. The center of the box in this child of preschool age is the central object of the influence of many factors: content, pedagogical, didactic, technique, language, and other. The introduction of early literacy is an excellent simulator for the classic literacy that a child will acknowledge in the senior group of kindergarten and in elementary school. There are many mobile applications for learning letters. We analyzed augmented reality application. The table shows the results of the analysis. No applications were found for learning Ukrainian letters. It was described to develop a new application for alphabet augmented reality. For the development of the application, a 3 cross-platform environment for developing computer games Unity was chosen. The environment has a rich set of tools for create 3D models in augmented reality. To write program models, the object-oriented programming language C# was used. Since there is support for the latest version of Unity. During the development of the application, an analysis of extended libraries and ones they carried out that allow displaying the determined shells object in augmented reality. It was necessary to even prefer to one of the ovophora. We choose the ovophora. You can see the characteristics on this slide. The main function of the application to study the Ukrainian alphabet. For these models of letters were created, which are shown in the figure 2. The application contains models of numbers and animals. For all letters, corresponding spawns and provided. For numbers, the sounds of the name. For animals, their sounds. Then you point the phone at the card, and then the 3D model appears. You can hear the sound. So learning takes place on the visual level and on an auditory and tactile level. Since the cards can be printed separate and the child can play with them outside of training in the application. In order to study the next map, it is another to point the smartphone at it. The figure shows an example of how the application works. This example. In the experiment, to took into account the new requirements for training and according with the concept of the new Ukrainian school. The main goal of which is to prepare a competent model Ukraine. Therefore, it is necessary to change the form, methods, and technologies of teaching. An experiment was conducted on the use of the developed mobile application with augmented reality among children. We carried out a survey of the participants in the experiments, namely teachers of educational institutions and parents on the city of Mariupol. This survey was designed to analyze and support further data collection on the current trend in augmented reality learning adoption. The objective of the survey was to collect another examples for software application to determine whether the mobile application was useful. For the study in the important idiom, they interpolate characteristic of learning, the speed of learning, the speed of memorization, and frequency of independent use of letters, which after the learning comes. Evaluation of success in terms of indicators was determined by two groups of several participants, teachers and parents. An analysis of the implementation of augmented reality application for educational and parents show in table 3. The figure 5 shows diagrams of the views of teachers, and the figure 6 shows the opinions of parents. To analyze the use of the development software according to the first characteristic, it was found that the speed of the child acquaintance these letters increased. This study became 2.5 times fast than without the use of augmented reality technologies. According to the second characteristic, the speed of the memorization increased according to the observation of parents and teachers from 10 days to 3 days and from 5 days to 3 days, respectively. They demonstrate the effectiveness of the use of the augmented reality technologies at different stages of the study of letters. The data of the third characteristic, the frequency of independent use, most likely demonstrate a well-designed application. This confirms the fact that the children tend to independently they use their own letters then performing tasks and in everyday life. They use the studied materials 2 times more than another the augmented reality. So the results showed that the learning system for letters and numbers then using augmented reality significantly increased the interest and self-efficacy of children. The speed of memorization, the material has also increased. Currently, augmented reality is one of the most activity developing technologies, which has also found its application in the field of education. Augmented reality technology opens up a new possibility for teachers and increased the interactiveness possibility of learning to studies of different age. This especially true for young children. The science 3D models have good visibility and high attractiveness. The mobile augmented reality application developed by us for Alphabet augmented reality provides an opportunity to study the Ukrainian alphabet, the names of numbers, the sound of animals. Since for application, the learning process is accompanied by the 3-dimensional visualization and sounding of each letter and number. An analysis of a survey of teaching and parents showed that when using an augmented reality application, the interesting and self-efficacy of children in learning letters and number significantly increased. They use the augmented reality application, increased the speed of memorization, the material, and help to retain the children's attention while learning a new material. In the future, we plan to visualization of study of cerebral shapes, colors to support the early literacy of children. Thank you for attention.
Thank you very much for your presentation. And colleagues, please question for presenter. Very interesting experience of using augmented reality for study of children. Можна я українською задам питання, бо в мене складності з перекладом того, що я хочу спитати. Так, от в такому ранньому віці, чи порівнювали ви, ну, можливо, якісь методи там тактильної гри або наочні прилади, які не передбачають використання якогось гаджету, приладу до візуалізації тої ж абетки там, чи якихось конструкцій мовних?
Дякую за запитання. Мені також можна відповідати українською, так?
Будь ласка.
На сучасному світі дуже важко дитину відлучити від смартфону. І з цим погоджуються багато батьків. дитина бачить, що батьки користуються смартфоном, тому вони також хочуть. І якщо, щоб направити саме використання смартфона у розвиток дитини, ми пропонуємо додатки мобільні для розвитку первинної грамотності. Це не є заміною будь-якого іншого навчання, яке використовується у дитячих садочках з кубиками або іншими тактильними предметами. Це є лише допоміжним засобом, який можете пришвидшити розуміння літер, кольорів та животних. Ми у майбутньому хочемо, щоб були насправді кубики. Зараз ми використовуємо картинки, надруковані на принтері, але у майбутньому це будуть вже тактильні кубики з буквами звичайні. І насправді дитина повинна буде складати кубики на слоги, і ось ці слоги при наведенні смартфона будуть також озвучуватись. Тобто це ми зараз демонструємо перший попередній етап використання. Але моя колега з Маріупольського державного університету з кафедри педагогіки, вона саме займалася апробацією цього додатку. Я відповіла вам на запитання?
Дякую за відповідь. Це така ідея виникла, поки ви відповідали, що дійсно можна зробити додаток з доповненою реальністю, який буде працювати наступним чином. Дитина може з кубиків викласти слово, простеньке, а програма буде візуалізувати.
Так.
Там кіт.
Тобто це наша майбутня ідея.
Бажаю вам її втілити. Будемо.
Сподіваюся, що
чекати на нові доповіді.
Дякую.
Чи будуть ще питання? Any question? У нас доповнена реальністю Сергія Олексійовича.
Я сьогодні слухала інші доповіді у іншій секції, і я вивчала насправді також досвід у багатьох вже учасників, які вже також і підручники застосовують, з доповненою реальністю створюють. І тому я знаю ваш досвід. Ми робимо лише перші шаги в своєму університеті.
Так, поєднання реального та віртуального світів через засоби доповненої реальності – це такий природній шлях нашого перетинання з того, що накопичено в віртуальних цифрових ресурсах, і те, що є в нас в реальності, що нас оточує, і таке інше.
Дякую.
Дякую вам дуже за доповідь. Thank you very much for your presentation. And we must close of our workshop. Ми маємо завершувати наш воркшоп, наш семінар. На сьогодні це була остання доповідь. Проте це не останній захід, в якому берете участь ви, в якому беремо участь ми. І ми дуже сподіваємось на зустріч вже найближчим часом, на нових наших заходах. І я попрошу Сергія Олексійовича коротенько зробити анонси, де ми можемо найближчим часом зустрітися, якщо це буде доречно. Але, перш за все, хочу всім дуже подякувати за чудові доповіді. Thank you for very interesting presentation and good work. И слово Сергею Алексеевичу.
Дякую, Андрію Миколаївичу. It's like a long and hard treasure. Not all can came to the conclusion, but we have really 9 high quality talks and excellent presentations, and I sure we have at least at week a second volume of this conference, workshop volume, which contain the proceedings of our workshop. You can see at our chat our meta site, which contains links to the nearest open events. First of all, I would like to invite you to our first, very experimental event, Digital Humanities Workshop, with very open thematics. For the first time, our publisher is International Conference Proceeding Settings of ACM. For the next year, we will have a lot of high quality events. For the educational, I would like to invite you for our traditional event, Jubilee, 10th workshop on cloud computing in education, cloud technologies in education, and or to 5 or to 6 workshop in augmented reality in education. You have a lot of time, almost half year, to prepare your submissions for this events. Next year we will traditionally 2 big conferences, International Conference on History, Theory and Methodology of Learning with wide thematics, and our 15 or 14 conference, Icon Method, International Conference on Mathematics, Science and Technology Education. This year, this conference involves 2 per-conference workshop. First of all, it's an edge computing workshop, very specific, will be held by Zhytomyr Polytechnic. And the next, the educational workshop, STEM workshop or STEAM workshop at Ternopil Volodymyr Gnatyuk National Pedagogical University. I would like to invite you for any of this event. We will try to make them not in hybrid, the real conditions by face-to-face participants, but what will be in future, I am not Nostradamus or even Cassandra, so we will try to do our best in this case. Андрей Николаевич, надеюсь, я все анонсировал или что-то еще забыл?
По-моему, все. Если что, действительно есть ссылка, есть наши контакты, и, в общем, мы не теряемся и обмениваемся всегда и новостями, и сообщениями о мероприятиях, в которых можно поучаствовать, можно быть просто слушателем, познакомиться с теми публикациями, которые выходят. В общем, мы на связи. Я единственное, что напоследок хочу сказать, очень жаль, что все-таки вот все еще продолжающаяся пандемия становится преградой для нашего живого общения. И здесь видно зал, но не видно вид за окном. В Херсоне сегодня замечательная погода. Организаторы конференции приглашают всех участников на прогулку речную, завтра, правда, на остров. И очень жаль, что мы все сейчас не здесь, не можем насладиться этой погодой, природой, последними теплыми днями осени. Будем надеяться, что все-таки, несмотря на те возможности, которые нам дают информационные технологии, общаться, выступать, делать доклады, не взирая на то, где мы находимся и в какое время, все-таки у нас будет возможность собираться, видеться и общаться лично. Ну, еще раз благодарю всех участников. Может, у кого-то есть желание что-то сказать. И также напоследок, если есть возможность, пожалуйста, включите камеры, все, кто присутствует, для совместного фото, совместного скриншота. Вот там возможность. Оно, честно говоря, пишет. Well, turn on your camera if it's possible, please, and smile. Cheers.
Goodbye.
Thank you